Hi guys, I Aziz welcome you to CoedMaster, and in this video I am going to talk about all the operations we can perform on binary heap data structure. I will explain the internal working of all the operations. So if you are willing to learn binary heap data structure in detail, then this video is for you. Make sure to watch this video till the end. So without wasting any time, let's get started. Alright guys, let's begin this video. So before I talk anything about operations on binary heap data structure, let's have a quick recap of previous video. So guys, in previous video we had learned about heap, what is binary tree, and what is complete binary tree. And we understood that heap is nothing but a complete binary tree. And there are two variations of complete binary tree, that is mean heap and max heap. In mean heap, the smallest element is present at the root, and in maximum heap, the largest element is present at the root. Then we saw the properties of binary heap, and these are: every node has at most 2 child, all the levels are completely filled except the last level, and last level will be filled from left to right. And we saw this example also, that this is a binary minimum heap, and this is the array representation of this binary heap, and this is the tree representation of this binary heap. And we saw that we can use this formula to find the parent of any node, and we can use these two formulas to find the left child and right child of any node. So guys, all of these things we have already learned in previous video. Now moving on to the next topic. So guys, there are basically 3 most common operations that we can perform on heap data structure. Number 1 is the build heap. In this operation, we construct the heap from the scratch. And to construct the heap from the scratch, we use the Heapify algorithm. I will talk about Heapify algorithm in a bit. Now the next operation is remove operation. So we perform remove operation to remove the minimum or maximum element out of the heap. If it's a minimum heap, then we remove minimum element, and if it's a maximum heap, then we remove maximum element out of the heap. The next operation is the insert new element operation. So whenever we have an existing heap, we can add new elements to the existing heap. That is where insert operation comes into picture. So these are all the 3 most common operations that we can perform on heap data structure. So let's start with the first operation, that is build heap operation. And in this operation, we are going to use Heapify algorithm. So let's say we are given random elements of array that are 10, 5, 20, 2, 4 and 8. So if we see the binary heap structure of this array, you would see like this: 10, 5, 20, 2, 4 and 8. And using this array, we have to build minimum heap. So what are the properties of minimum heap? So the first property is the value of root node is smallest among all the nodes, and this property is true for all the subtree. And if you look at this tree structure, it is violating these two properties. So in case of minimum heap, the root should be minimum among all the nodes. So if you look at this structure, 10 is the largest element, okay, and that is present in root. This means it is violating this property, okay. And if you look at these subtrees also, let's say 5, 2 and 4, 5 is the largest element, but in case of mean heap, we need smallest element at the root. And here also, if you look at the right subtree also violating this property, okay, because 20 is greater than 8. So basically this structure is violating properties of minimum heap. Now let's see how can we use the Heapify algorithm to balance this tree and to convert it into minimum heap so that it follows all the properties of minimum heap. So what Heapify algorithm says, that you have to heapify all the nodes starting from bottommost, rightmost inner node until root node, and apply the heapify recursively on all the subtree. So this is what the algorithm says. Now the question over here is, what does it mean by heapify? So let's understand the heapify operation using this example. So in this example, we have a tree, and this tree has 3 nodes. And in case of minimum heap, this tree is violating the property of minimum heap. Okay, you can see that 10 is the largest element and 2 and 8 is the smallest element. So what we do in this case, we find the smallest among all the elements. So in this case, the smallest among all the elements is 2. So we are going to swap this 2 with the root element. So after swapping 2 with a root element, we get the minimum heap. And you can see that this minimum heap satisfies all the properties of minimum heap because the root element is the smallest among all the elements. So this is how Heapify works. Now let's apply the Heapify on this array and try to convert this array into minimum heap. So these are all the elements of array, and this is the tree representation of this array. Now we are going to start with the bottommost, rightmost inner node, okay. And how to find the bottommost, rightmost inner node? It's simple. The bottommost rightmost inner node is nothing but it's a parent of last node. So the parent node is 8 and the index of this is 5. So we are going to compute the parent of this node. It's going to be 5 minus 1 divided by 2 is equal to 4 divided by 2, that is equal to 2. So the parent of this node is present at index 2. So we are going to start with index 2 and apply Heapify recursively. And then we go to index 1 to apply Heapify algorithm recursively. Then we will go to index 0 to apply Heapify algorithm recursively. Now let's start with the second node, okay? So in second node you can see that it has only left child. So we are going to find the smallest among two elements. So smallest among 2 is 8. So we are going to swap this 8 with the root node. So after swapping we get structure like this. And then we are going to again call the Heapify recursively on the subtree. So the subtree of 8 is 20. So in this subtree it has only one node. So we do not have to do anything, we just stop here. Now this subtree satisfies the mean heap properties because the 8 is the smallest among all the elements. Now let's apply the same algorithm on index 1. So on index 1 we have 5 and then its childs are 2 and 4. So let's find the smallest among all three elements. The smallest among all three elements are 2. So let's swap this 2 with the root element. So after swapping 2 with the root node, we get the structure like this. Then we are going to apply the Heapify to the subtree. Okay, the subtree of 2 is 5. So this subtree has only one node, so we do not have to do anything, we just stop here. So we are done with the index 1. Now let's move on to index 0 and apply the Heapify algorithm. So at index 0 we have 10. So we are going to find the smallest among 10, 2 and 8. And the smallest among 10, 2 and 8 is 2. So we are going to swap this 2 with 10. Okay, so after swapping 2 with 10 we get this structure. Now again we are going to call Heapify algorithm recursively to its subtree. So subtree is 10, 5 and 4. So the smallest among all three elements is 4. So we are going to swap 4 with the root node. So after swapping 4 with the root node we get this structure. And now you can see that this structure satisfies all the properties of minimum heap. That the root node is the smallest among all the nodes and this is true for all the subtree. Subtree 4 is the smallest among all the elements and on right subtree 8 is the smallest among all the elements. So guys, this is how Heapify algorithm works, and using Heapify algorithm we can build heap from scratch. So I hope this is clear to you. Now let's move on to the next operation, that is remove operation. So what happens in minimum heap, we are going to remove the first element to get the minimum element out of all the elements. And in case of maximum heap, we remove the first element so that we get the maximum element out of all the elements. So let's say we have a minimum heap like this 2, 4, 8, 10, 5, 20. And this is the array representation of this minimum heap. Okay, and the size of this array is 6 and the capacity of this array is also 6. Now what happens if you are thinking that we can simply remove this element from here? Then you are wrong, my friend. Why? Because if you merely remove this element, then it would look something like this. So we have an empty element here and we also have an empty element in the array. So because of these empty element, we are just making this array as invalid array. And because of invalid state, we are not able to call the Heapify algorithm on this array. So this is not the good way to remove the element. So let's put it back. So in this case, what do? We are simply going to swap the root element with the last element like this. So after swapping root element with the last element, we get the tree structure like this. At the same time, we are going to reduce the size by 1 so that we are only considering elements from 1st to 4. So this means the top element is removed and we are left with only these elements. Now you can see that this 20 is violating the property of minimum heap. So we have to move this 20 to its correct place. Okay. So to achieve these, again we have to call the Heapify algorithm on this node. So what do? We find the minimum among all the elements and minimum element among 20, 4 and 8 is 4. So we are going to swap this 4 with the root element. And after swapping, we get the structure like this. Again, 20 is not at the correct position. So we are going to call Heapify recursively to this node. And that is a subtree of 4. So the minimum element among 20, 10 and 5 is 5. So we are going to swap this 5 with the root node. So we get 4, 5, 8, 10 and 20. Now you can see that this tree is perfectly balanced and this tree satisfies all the properties of minimum heap. Okay, so 4 is the smallest among all the elements and this is true for all the subtree. So 5 is smallest among 10, 20 and 5 and 8 has only one node. So guys, this is how remove operation works in heap data structure. I hope this is clear to you. Now let's move on to the next operation, that is insert operation. So what happens if we want to add new element to existing minimum heap or maximum heap? So let's say we have this minimum heap 2, 4, 8, 10, 5, 20, and this is the array representation of this minimum heap, and we want to add new element 1 to it. So what happens? We simply add 1 to this array. So after adding 1 to this array, we get the heap structure like this: 2, 4, 8, 10, 5, 20 in 1. Now you can see that 1 is violating the property of minimum heap because this is the smallest element that should be present at the root, but right now it is present in the leaf of the tree. So what do we do in this case? We are simply going to compare this node with the parent node. If the value of this node is smaller, then we are simply going to swap this node with the parent node. So after swapping, we get a structure like this: 2, 4, 1, 10, 5, 2, 20 and 8. Now again you can see that 1 is again violating the property. Now again we are going to compare this node with its parent node. Okay, so parent node is 2, that is greater. So we are going to swap 1 with 2. So after swapping 1 and 2, we can see that we get the perfect minimum heap, and this heap is satisfying all the properties of minimum heap. So guys, I hope now you have a solid understanding of all of these 3 operations, that is build heap, remove operation and insert operation. So these are the most commonly used operations that we can perform on heap data structure. So this is all from my side. If you learned something valuable from this video, then hit the like button in order to make YouTube algorithm happy. Please subscribe to this channel and don't forget to click the bell icon so my friend you never miss any upcoming videos. So thanks for watching. See you in the next one.